All right, I think we are ready to get going this morning. Shuffle the chat window here to the front. Okay, hello everyone. My name is Tim. I go by foamyguy on Discord and GitHub. In this stream, we're going to be working on a CircuitPython project. If you've never watched any of these streams before, if you don't know what CircuitPython is, CircuitPython, this is the website for it right here, circuitpython.org. This is a version of Python that runs on these tiny computers called microcontrollers. I've got this one loaded up here, which is a PyPortal device. This one has a nice, relatively big, like 3 inches or so touchscreen on the front of it there. It's also got a couple of sensors and things like that. But these microcontrollers, they come in all shapes and sizes, different formats with different amounts of pins and different built-in hardware and all of that sort of stuff. So this is a way that you can write programs to run on these devices. And it's meant to be very quick and easy to use, especially for folks that are brand new to coding. So the way it works is the device, when you plug it in, it shows up on your computer as a CircuitPy drive like this. On that drive, there will be a file called code.py, and you just write your code into that file. And as soon as you save it, it will start running. So it's doesn't require a lot of hardware or software. You don't have to have a special programmer device. You don't have to have any kind of special software. You can use pretty much any text editor. You don't have to load any drivers or do anything like that. It all just kind of works out of the box on all of the common operating systems. So that's really nice. If you want to help out the CircuitPython project, if you're interested, you can get involved. Actually, you can contribute to the project. It's open source. So on circuitpython.org, there's this link up here, contributing. You can go to there. It's going to list off open pull requests and open issues that are in all of the CircuitPython libraries. So if you're brand new to the project, this is probably the best place to start. You can kind of go through the pull requests, look for something that interests you, and then you can do a review on that pull request. You can go check the code, see if everything looks good, see if any if there's misspelling or anything like that in comments. That's kind of relatively easy stuff that even beginners without any prior experience can look at. If you have the hardware for it, you can actually go ahead and try it on one of your CircuitPython devices, and then just report back if it worked or not, or if you ran into any issues. If you want to get involved a little bit deeper, the kind of next level of thing that you could do is you could look into open issues. So these are issues where there might be a problem, or there might be a new proposed feature or something like that. So you could find something that interests you. You could work on that and then end up actually creating a pull request for it. The core project itself is also open source. That's on GitHub right here, github.com/adafruitcircuitpython. So if you want to get involved in the actual core project itself, you can do that as well. And it has the same issues and pull requests there that you can go through and take a look at and get involved in. Also definitely encourage you, if you do want to get involved, to join us in the Discord, which is linked down below in the stream right there, adafruit.it/discord. And for this chat, I'm in the live broadcast room, but there are a couple of other rooms, including a CircuitPython dev room, which is where lots of the developers that work on the project are hanging out throughout the week. Last thing to note is CircuitPython, it's an open source project, but it is primarily funded by this company, Adafruit. This is their website, adafruit.com. They are a hardware and software company based out of New York. So if you want to help support the project, but you don't want to get involved in the development, this is the other way that you can do it, is by purchasing hardware from Adafruit, since they're the folks that are paying the developers and the community leaders and things like that. They're paying out full-time jobs to these folks to help run the project and develop the code and all this stuff. So if you go ahead and purchase hardware from them, then you are helping, ultimately support the project by keeping the lights on, keeping the bills paid, all of that sort of thing. So today, like the title says, I'm going to be working on a digital Etch-A-Sketch. This is an idea I've had in mind for a little while. It took me a little bit to get the right hardware for it. It uses these rotary encoder I2C breakouts, these things right here. So this is product 4991. And these things are nice because you can hook up a rotary encoder onto it, and then they connect through these stemma cables right here. So There's really not a whole lot of soldering or anything like that needs to be done. The rotary encoders did need to be soldered down, but that's pretty much it. The rest of the connections all go through these stemma cables here. And so the other nice thing about these is that you can chain them together. So this is a picture of 3 of them chained together, and on my camera here I've got 2 of them chained together and plugged into the PyPortal device. So the kind of base idea for this project is, we have 2 knobs essentially, right? Rotary encoder is pretty much just a knob that we can read from the microcontroller. And so we're going to use those 2 knobs essentially to simulate the knobs on an Etch-A-Sketch, and we're going to draw on the screen, all those pixels and lines that get filled in. So if you're not familiar with Etch-A-Sketch, we'll pull up maybe an image of that real quick here. It's one of these little toys right here. And so this is I don't even know when this toy got first invented. It's quite old at this point, I would imagine. And the original toy, it doesn't require any batteries or anything like that. There's not a computer inside of it. It's actually just like, I think it's like magnetic dust, and then it has a little magnet that gets dragged along by the knobs. And so when it gets dragged along, it pulls up some of that magnetic dust to where you can see it through the front side of the screen there. And of course that makes it, like draw a line within that dust. So, you can see a couple of different things that people have drawn with them, ranging from, the very simple here. This one just says no batteries. Let's see if we can, these are ads at the top here, I see. I wonder if we can just get a bigger picture. Yeah, there we go. So this one, it's just some relatively basic text. But some people also, take these things to the extreme and make like really photorealistic images and stuff. So you can see some of these here that are done by folks with quite a bit more talent. And so I will not lie, I definitely do not have the ability to make some of these fancy ones. Even with the digital one that we're making on the PyPortal, like I don't think I'm going to be able to make anything particularly fancy with it, but I do want to do it because I think it's an interesting and neat project idea. So eventually I'm going to end up printing a case, I think, that will hold the PyPortal and the 2 knobs, with the 2 knobs down below it like this. But in this stream today, we will be working on the CircuitPython code to make it work first. And then if we get the code done, maybe I'll start doing the model for the case. I don't know for sure. I don't think I've done 3D modeling on stream before. Typically I work on CircuitPython or Python code. But maybe we'll delve into that if we get the CircuitPython done. But we're definitely going to start in the CircuitPython world. And I have this code loaded up here. This is just kind of like the most basic example for reading the stemma rotary encoders. So I've got the 2 encoders hooked up. I can turn each one of them, and they both get read out individually. So as I turn this one, we can see it says encoder position 1, or excuse me, encoder 1 position, and then it's changing up and down based on when I, turn it clockwise or counterclockwise. And on this one, same thing. It's just reading out the current value of the encoder. But this one is saying encoder 2. So we have it set up to where we can read each of those independently, which is perfect. So now we just need to build the rest of the program, right? We need to take these values that are coming from the rotary encoder. We need to translate them to essentially XY coordinates on the screen, and then draw a line at that XY coordinate and have it follow along with those encoders as they are moving. And so there's actually a library that behaves a little bit like that, which is called the Turtle library. If you're familiar, or not familiar, I should say, with Turtle programming, you can probably find something like this, Turtle programming. If we search this up, I'm guessing there will be similar stuff. Yeah. This is a kind of programming where you have, like a cursor, essentially, and sometimes the cursor is drawn, it's depicted by a turtle. So that's why they call it this. And the idea is like you can write code that tells it to like move forward or turn by a certain amount of degrees, or, like move left a certain amount of pixels, or move right a certain amount of pixels, that sort of thing. So, in this one, they probably had the turtle start here. it moved up quite a few pixels there, and then it kind of went around in a circle like this by moving a little bit and then turning and moving a little bit and turning and moving a little bit and turning, so on and so forth. Hey there, Johnny. Oh, nice. Deploying a web app today. Cool. Yeah, I just did. Well, we didn't do the deployment yet. I'm working on a web app right now at work, though. And so this is kind of like the core idea of turtle programming, and there's a bunch of different languages that support this turtle idea. You know, this is a common idea across many different languages. You could probably find a way to do it in the browser. I'm sure if you search something maybe like JavaScript turtle, I would imagine it will come up with some way that you can actually do this kind of stuff right in your browser. And so CircuitPython has a library that implements this same idea. And so that is the library that we are going to use for the Etch-A-Sketch, because it's already pretty close to what we want to do. It has a cursor, it moves in certain directions, it can turn. And so that's pretty much what we want for the Etch-A-Sketch, right? We're going to move based on those knobs turning, and then based on whether which knob we turned and whether we turned it clockwise or counterclockwise, then we'll turn the turtle, in 90-degree increments, right? So one knob, when you turn it clockwise or counterclockwise, it will cause the turtle to point north or upwards and then make it move. If you turn that same knob the opposite direction, clockwise, then it will go, south, downward, and it will move. And then the other knob, of course, would be for right and left. And so that behavior is actually pretty close to what we want already in this turtle library. So I figured this would be kind of like the perfect library to use to make this. One thing I'm going to do real quick, it's a little warm in here. I'm going to turn on a fan real quick. A little bit of air moving here. And so where do we want to start here? I think what I'm going to do to start is... So first I'm going to rename this file here to Encoder, stemma Encoder Test or something like that. And I'm just going to do it outside of PyCharm here. I've got my PyCharm loaded up here, pointing to my CircuitPy drive. So we're going to just change this over to code stemma Encoder Test. And now we'll make a new CodePy file. And I think to start with, I'm actually just going to write some pseudocode. I'm going to fill in some comments with the basic logic that say what I want to do. We could make a while true. We're definitely going to have a while true. We could put a pass inside of it for now. I guess maybe let's put the pass at the top. We'll just work down here. So we need to read the encoder values. Encoder values. This does not want space in that line. Okay. So I don't know which encoder is which, honestly, in the Etch-A-Sketch. Maybe I'll pull up a video of an Etch-A-Sketch on YouTube or something. I want to say that it's the right knob is up and down and the left knob is right and left, but I'm not actually certain of that. So I think what I'm going to do in my pseudocode here, I'm just going to refer to them as like up-down encoder and left-right encoder. So if up-down encoder value is different, so I'll say if it changed, if the encoder value changed, then inside of here we want to do if it went up, then we are going to move, no, we're going to turn. So if it went up, I think is that clockwise? Counterclockwise. Maybe we should bring back our encoder test code actually real quick here. Or the other thing we could do is just in the the pseudocode, I could just call it clockwise or counterclockwise, maybe. Code ostemma. Get a lot of files on my PyPortal. Here we go. I'm gonna grab this real quick. Throw it right back in here. We're gonna end up reusing some of this code anyway, so maybe we'll copy paste it out of here, I think. And I guess I'll just use the camera actually for now. Okay, so when I turn clockwise, the number is going up. And is that the same here? Yes. Okay, so clockwise is making the number go up. So I'll just take the rest of this code back out of here for now. Clockwise is up. So if it went up, that means we turned it clockwise. So we'll say that we want to point the turtle north. And I'll just use north, south, east, west for the directions. Point the turtle north. And we also want to move the turtle 1 unit. If it went down, and this is the value of the encoder. If it went down, then we will point the turtle south, and then we'll also just move it by 1 unit. We could maybe we'll also have another if statement here that's like if it's not already pointing north. I don't know if it matters necessarily. I mean, if we point it north and we were already pointed north, it's probably not that big of a deal. But we could maybe add a little bit of extra logic as well that says like, you know, if we're already facing north, then don't change. But I'll leave that out of the pseudocode. So then the other thing we want to do here is if the right left encoder value changed, then we want to do a similar kind of thing here. I'm actually going to copy all of this, get it indented back. Okay, so if it went up this time, we were going to move the turtle to the right, which is east. The turtle 1 unit, that stays the same. This will be point the turtle west, so go to the left if it went down, counterclockwise. Move it 1 unit. Okay. So this is really the core logic of our Etch-A-Sketch. I think eventually, once we get this part working, it'd be cool to go above and beyond and maybe make it so that when you press the buttons, because these encoder buttons, they can be pressed down as well. I don't know if you can tell that I'm doing it, but I'm pushing it down. And you can see there that the program is recognizing when it gets pressed and released. So maybe as kind of a bonus thing, once we get the core logic working, then maybe we'll make it to where you press the button and it could change the color. Or maybe it could like lift the pen so that you can spin the knobs and move to a new location but not draw a line to there, which of course you cannot do on the actual Etch-A-Sketch. But since we have a digital screen, we can certainly do that using our turtle. So we'll work on the core logic, but then maybe we will try to enhance it a little bit, make it even more fun, or at least, you know, more possibilities than the original Etch-A-Sketch. So let's start coding this up. We can copy a lot of the code from this one to set up the encoders. We will set up our 2 seesaws. I want to use 1 and 2. I feel like I should maybe use up, down, and left, right. Just so the code is a little more self-commenting, right? Right, and we'll figure out which one is actually which later on, but one of these, the way this works is these have different I2C addresses. So there's actually these 3 pins here, A0, A1, and A2 over here, and you jump them. So if you leave all of them open, then you get the address, I think it's 36. Yeah, 36 is the first one there. But if you jump, one or more of those pads, then it will change the address. So in this image here, it has A1 connected with a little solder blob. And this one up here, it's got A0 connected with a little solder blob there. No, I didn't know that. C-Films, new category. I'm not sure, what category are we in right now, actually? Are we in Science and Tech? I know, actually, just the other day, I was watching a stream where they were talking about that, and they were saying it'd be really nice if they did have a game development specifically, is what they were talking about. I'll have to check into that though. Yeah, that's pretty cool. I would go under that one definitely, if that is existing now. Thanks for the heads up there. So I have one of them jumped on one of my Stemma encoder devices. I have connected one of those 3 sort of address pads, and so that's why I've got 136, which is the one that's all open, and 137, which is the one that I soldered. So next we will we can go ahead and do this part. This is probably not necessary for the actual code to work, but it's checking the version of the firmware that is actually on that encoder device. So that encoder device, it has a Seesaw chip on there, which is I think like SAMD09 or something like that. It's a even smaller microcontroller than the ones that we're used to using. Yeah, I would agree with that too, C-Films. The animals and pets, that would be a good one as well. Because yeah, Science and Tech, it's like half people programming and half like animal wildlife cams and other stuff like that. There's like an earthquake cam and stuff like that, which is, I guess, sort of science-y, but not really. So yeah, animals and pets, if they would add that one, I think it would help quite a bit as well. But I will say, getting a software and game dev, that's like, that's a big step, just because we could get out of Science and Tech, and Science and Tech could be more for the wildlife cams and stuff like that if they don't end up making an animals and pets. So here, instead of 1 and 2, we're going to use these ones up, down, and left, right. So this is going to check the firmware version. And basically, if it's not, this is the firmware version that it's supposed to be. So if it's not that, then, we just print a little warning right there. Maybe we should raise an exception or something. Probably the rest of the code might not work, depending on if it's like, lower version or the wrong version. Yeah, I'm doing good, C-Films. Doing good. Yeah, I hope you're having a good day. All right, so we'll print those. We can grab some more of this code. So this is setting up the actual Seesaw, like initializing the Seesaw devices. So Seesaw, if you're not familiar with it, again, it's like a SAMD09. I think it's a smaller microcontroller, and it's got a bunch of I/O pins. And the idea is like you communicate from the main microcontroller. In this case, the Pi Portal that I have here. This Pi Portal has a SAMD51, this big main chip on the back here. It will communicate. Oh, nice. Nice. Yeah, good to hear. It will communicate with the Seesaw, and it communicates over I2C. So it's got like an I2C connection through these cables, and it's able to tell the Seesaw to, turn on and off those I/O pins and connect up with those actual hardware peripherals that are plugged in. So it's kind of like a fancy version of a port expander. Hey, thanks for the follow, C-Films. I appreciate that. It's kind of like an even fancier version of like an I/O expander. So we got to initialize these things. Hey there, Dexter. Having fun with the Pi badge today? Nice, nice. Pi badge is a fun one. Pi badge is pretty much like the first. Well, it's not the first CircuitPython device I had, but it's the first one that I really started playing with a whole lot. So I had a Circuit Playground Express, and I played with that one a little bit. But when I got the Pi badge, mine was actually the Edge badge, but it's basically the same device. When I got that one, that was when I really kind of dove into CircuitPython. And especially display I/O stuff, right? Folks that have watched the stream before will know that I tend to work on display I/O related stuff, microcontrollers that have screens and drawing stuff on the screen. That Edge badge was really when I got into that stuff and got the bug ever since. So button 1, we're going to do the same thing here. Button up, down. Button up, down, held. Encoder 1, this is going to be encoder up, down. Next to Seesaw, up, down. Last position, up, down. I think this is the last button position as well. I think we'll end up making, or is this, no, maybe this is value. I don't know, we'll see once we get a little more of the code. The encoder value. What are my main coding languages and what do I do with them? Good question. So I would say at this point, probably the primary language that I use most frequently is Python. But the language that I have the most experience with is Java, or more specifically Android. So I have been working full-time as a software developer, started out doing mostly Android apps, but more recently we also created a server that's built with Python and Django that those Android apps connect to. So a lot of my work these days is actually more on the server side than it is on the Android side. But those are definitely my two most used languages. The two most experienced ones I have. I've played with some other stuff as well. Like, obviously part of making a server is web development, right? So JavaScript, HTML, CSS. I wouldn't call myself, super good at, any of those three things, but I do, work on those quite a bit as well. So this is going to be Seesaw right, left, or left, right, I think is what I called it before. Yeah. Maybe we should call it right, left, though, because, it's just a preference thing. It doesn't really matter, but I think up is going to be clockwise, and I think right is also going to be clockwise. So let's keep those in the same order, where the clockwise one comes first. Again, it doesn't really matter that much, but HTML, CSS, JavaScript, PHP, SQL, and Python. Nice. Nice. So you must probably work on web, like web applications and stuff like that. Is that kind of stuff you build a lot? All right, Seesaw right, left. Change this one over. So same thing here, right, left, right, left, right, left, and we'll rename these as well. So button, right, left. Nice. Web development database. Yeah, I like, on the web applications that I do, I use Django, and one of the nice things about it is it has a ORM, object relational mapping layer, that's built in, and so it's backed by a SQL database, but you don't actually have to write the SQL code for it. It's all object oriented. You just can be like, my car objects, and I want to look up all the ones that are, model Ford or whatever, right? You just give it like arguments in the Python code, and it will figure out the SQL for you, which is really nice. Encoder right, left, Seesaw right, left. So this will be right, left. Oh, nice. Yeah, data analysis. That's something I haven't ever gotten into too much, but it seems interesting to me. I'm sure one of these days I'll end up playing with it a little bit. Data analysis and statistics and visualizations and stuff. Have you ever messed with microcontrollers, C-films, like these little devices we're playing with here? Encoder, left, right, left. Okay, that looks good. So next, let's grab some more of this code here. Okay, so we're setting the positions that we get from the encoders. And there's a comment here that says negate in order to make it clockwise, so we'll just leave that. You get rid of pass at this point. I've not learned hardware yet. All right. Well, if you ever do, if you're interested in it, I'll tell you, man, CircuitPython makes it super easy, especially if you do already know Python, because you can kind of reuse a lot of those Python skills to play with the hardware devices. It's gotten a lot easier than it used to be, I'll tell you that. Position, so this is position up, down. Except we don't want last position. Just type that one there. Strongest programming is PHP. Probably Java. Java Android is my strongest language, and just because I had the most experience with it. Also, Java was one of the first languages that I really learned. I learned Java in high school, so that was, over 10 years ago, and I've been working on it relatively steadily since then. The last, coming up on 10 years, I think actually. I hit 9 years this year, maybe, at this job. So, and I've been using Java and Android the whole time that I worked at this job, so I've been using that the longest for sure. So this will be encoder up, down. Position right, left. Encoder right, left. I would say though, that's the one I am the strongest in. That's the one I have the most experience in, and the one that comes, the most naturally to me if I'm like writing something from the ground up. But I will tell you, Python is the one that I like the best. I like Python a lot more than I like Java. I think Python is it's a more fun language to write. It tends to be a little bit easier to get things done than Java. Java's got a lot more boilerplate code, copy paste this big chunk of code that just is the way it is because that's how it works. Like if you ever use Java, it's like public static void main, string args or whatever, right? Like you have a bunch of just really verbose stuff that doesn't really mean much to you if you're just trying to make a basic program. Whereas Python, it's kind of like just your program is there and it runs, and you could just put print hello or something. You don't have to worry about learning too many of these different things or even copy pasting too many of these different things. So I've grown to really love Python. Okay, so this is going to set the current positions of these. So next we can, well, this is reading the encoder values. So we could actually put this here. That was from our pseudocode. So we'll start kind of filling in the real code kind of in our pseudocode here, so that by the time we're done, we'll have it be, nice and commented. So if the up-down value changed, so if position up-down is not equal to last position up-down, then the next thing we want is if it went up. So in here we'll say if current position is greater than last position, and point the turtle north. So we'll need to, we'll need to initialize the turtle. And I do not know off the top of my head how to do that. So actually another thing that we'll probably do is we might go and run some examples from the turtle library just to get a sense of API for that. Let's start here. Examples. Actually, quite a few. In simple test. Okay. Gonna import it. I'm gonna pip install these if they will work. It's on PyPy. Yeah, it is setup.py. Name of it. This is gonna give me type hints and code completion and stuff in my PyCharm here. Pip install turtle, also Seesaw as well. I haven't used Python for web dev yet. Oh, I gotcha. Yeah, I really like that as well. Django specifically is super nice in my opinion. CircuitPython, GitHub. Python, you're developing a calculator and a new programming language. Wow, that's pretty cool. Seesaw. I could probably guess the names of these. They use a fairly standard thing, but kind of a copy paste type of person. Pip install. So you see here, these are red currently, but now they're no longer red. So by installing that in pip, it gave it to where my IDE knows what those libraries are and what all the functions and stuff do. So that's kind of nice. Whoops. Yeah, pull this chat back up here. All right. Okay, so let's go back to that turtle example. We'll probably run this example as well and just play with it for a minute to just make sure we know what the turtle API is like. But I'll put a couple more bits of this code in first. Initialize the turtle. Word.display, yes. Okay. Set heading. This is how we will turn. You know what we should pull up also is the docs. Code named McFly. That's awesome. Fan of Back to the Future, I'm guessing. Let's go here. Let's look at set heading. I suspect it will have. Yeah. I don't know what's logo mode versus standard mode. These are helpful. So essentially 0 is east. 0 is east. North is 90. I'm going to make some variables for those, just so that way the code can say like east, west, north, south without having to remember what's what. So east is 0, north is 90. Nice. Yeah, Back to the Future is fun time. East, north. So then west would be 180. And south would be 270. So now that we have those variables in the code here, we can say point the turtle north, and our code will actually pretty much say that exact thing in English. So that's nice. Turtle.set heading north. Okay. And I'm actually gonna stop for just a minute on this code, and I'm gonna play with the turtle example just to get my bearings a little more with the turtle API. So what I'm gonna do is save this. I guess it's probably gonna crash or not do anything just yet. Yeah, it looks like it crashed. Let's see here. crashed because it tried to do a greater than on none. But what we're gonna do is actually go and rename this for now to code Etch-A-Sketch. Etch-A-Sketch. And then we'll make a new code and we'll put the simple test from turtle inside there. And let's run this one. Okay, this is what this one's doing. So let's simplify it even farther though. We could do it this way maybe. Let's go we'll mess around with the colors at some point as well, but for now I'll just leave it on blue. So let's do .goto. So goto is that two. Y1 is none, then X1 is a pair. Move the turtle to an absolute position. The pen is down, then draw the line. Doesn't change the orientation. Okay, I don't think we will need that for our program. We're always just going to be moving like, you know, by one thing, like going forward in whatever direction we're facing, and moving by one. So one second. Sorry about that. Kitty cat's trying to get into stuff as usual. Let's not do go-tos. Let's not do pin-ups for now. Down, we probably don't need pin down. I'm guessing it's probably starts pin down. So let's take that off. Don't really need start. Okay, so let's just go real basic here. Let's go turtle dot forward. I don't know, 10. Let's see what this is doing here. Okay. Maybe we do need pin down actually. It didn't draw anything. Yeah, maybe we do need pin down. Turtle pin down. Yeah, there we go. Okay. And what's our current heading is 90. And we're moving east. I thought we said east was 0. Say east was 0? Yeah, we said east was 0. Set heading. If we set heading 0, make this a little bigger. Okay, 0 looks like is north. Mode. Standard or logo? What's logo? There's set mode? Change the mode. What mode are we in by default? Okay, so now we need to see the output that we just printed, which we could try to look on the screen, but the thing is the screen is taken over by the turtle, so it's showing what's been drawn now. So we need to actually connect to the serial output. We can use TO like this, and then relaunch this code. Mode is logo. What is logo? I think we should change the should change this. This is unclear to me. We defaulted to logo. But this right here says logo mode 0 east. But we definitely set heading to 0 and moved north. Zero north. Okay. I think we should change this. This is not very... This is kind of hard to understand in my opinion. We should just make like standard mode colon north, south, east, west. Like all four of them in standard mode, and then next line down, logo mode colon north, south, east, west. Honestly, I think that'd be a lot more clear. So I think it's... These things are together. This is saying standard mode's on the left side of the pipe, logo mode's on the right side of the pipe. But that's totally unconnected from this idea right here, which is saying in standard mode, 0 is east. In logo mode, 0 is north. And then these right here are the next one, but there's no comma or anything. And that says in standard mode, 90 is north. In logo mode, 90 is east. And is that right? If we go 90... do move east, yeah. That's supposed to be rendered as a table. That's a good question, actually. I don't know if... Yeah, that's a good question. Maybe that's why the pipes are there? A table would be fine too, yeah. Just as long as it's like... You're not having to try to do this whole left of the pipe, right of the pipe thing. Yeah, hey, thanks, Highlange. Yep. Could read like a table. And Dexter as well on Discord chat there. So maybe I'm gonna keep going on the Etch-A-Sketch thing, but maybe a little later on in the stream we'll pull up the turtle library and make a PR. Try to clarify that, or see if we can do a table and fix it up a little bit. For now, though, I think we got it. So we will need to change our variables, right? Because 0 is north. $90 is east. 180 is south. $70 is west. Okay. Okay. So set heading, pin down, we can do that kind of at the beginning. I think it should be a table. Yeah, we'll try to make it. We'll have to look up Sphynx, Sphynx documentation table, something like that. I don't. Maybe might not be able to render tables, or there might just be like extra spaces, or Lord only knows. I will say Sphynx. Sphynx is what makes these documentation pages, and it's very, very particular on its syntax. Like if you have one extra space or not enough spaces or anything like this, it does not end up rendering it. Sometimes it won't render anything at all, but other times it will render and not be right. So it's very possible that it could be supposed to be a table. The other thing is maybe it makes more sense in the code. Like if we look in the code, maybe it's actually not as jumbled up. Let's look in, whoops. I don't know if I have turtle. Let's take a look. I'm gonna have to get up in a minute and shoo the cat away. Where am I going? Where am I going? Okay. Repo. Turtle. Window. Sure, we're on the latest version. Yeah. Okay. Yeah, buddy. Okay. Yeah. That does make a lot more sense. So yeah, either Sphynx, either this is not the right syntax, or maybe the syntax changed from one version to another, or something like that. Something went wrong with this though, and it's not ending up looking correct. I don't like him. He's trying to like sit right behind me, right? I'm on a bouncy exercise ball, and I don't like him to sit right behind me because it can roll and then squish his little paws or something like that. Or the other thing is he has popped 2 or 3 of these balls already by sticking his claws into them, so I also don't like him to be right next to it. Alrighty. Have to chair for a while. He gets interested in something else. Okay. So yeah, we'll I think a little later maybe we'll make a PR and play with that a little bit, see if we can get it to render correctly. But for now, let's continue on, I think. So yeah, this is actually really pretty much all of the Turtle API that we need is just, hey, stop. Okay. Yeah. 1 second. Come on. Stop. Can't have nice things. All right. Let's see. Am I way lower now? No, it's still pretty good. All right. Where are we at here? So this is really pretty much all the API we need, isn't it? We're going to be setting heading north, south, east, west. We're going to be going forward by 1 every time. Pin down will just be down at the beginning. We won't bother going up ever at this point. Eventually, I think we'll change it to where you press a button and it can go up or down. But for now, we're just going to stay down. So let's rename this code to code turtle. Well, it's not actually the simple test. I'll just put turtle test. Let's put Etch-A-Sketch back to code. Code. Okay. And we fixed these now, so north is 0. So this is setting the heading to north. Hey there, beep boop beep. Appreciate the follow, thank you. So we want to move by 1 after that. Turtle dot, it's forward 1. Maybe we'll end up changing the units. Maybe we do 2 or 3 or something a little bigger than 1. We'll start with 1 and see how it works though. If it starts feeling like it's going, you know, too slow, like it's not moving enough when we turn the knob, then we could increase this, or maybe we could even make a step size variable or something like that. That way we could change it over time, but start with just 1. So if it went down, which is just going to be else right here, value, I'll say position went down. Point the turtle south. South. Try to keep these comments above the line of code that they were also here. Let's do that. Turtle dot forward. Okay. So next we have this one here. If position right left is different than last position right left, if position right left is greater than last position right left, turtle dot set heading east. Actually, this is clockwise. Yeah, no, that's right. That's right. East. Turtle dot forward. Okay. Else. Position went down. Okay, turtle set heading west. Move it by 1 unit. Armbands either. Forward. Okay, so the other thing we need to do, which I did not make pseudocode for, but we need to set the last position variables. I'm going to say update. So last position right left is equal to position right left. Last position up down is equal to position up down. So is that all we need right now? This might be all we need right now. Let's give it a try. Something crashed. Oh, right. That was the same error we saw before, which is that we're trying to do greater than or less than on none. I think these should they start on 0 or just start on position? There we go. So now it's going to start on the position that the encoder is at, which I guess is probably 0, but I'm not sure. Yeah, thank you, Highlange, or yeah, H-Lange. I'm not sure how to pronounce your name, so I apologize if I got it wrong. So now, yeah, that is awesome. Okay. Oh yeah. All right, we are here. We have the most basic. We have the most basic one working. That is awesome. Okay, you're gonna have to bear with me while I just play with this for a minute because honestly, I just think it's super cool. Again, I'm not the most talented Etch-A-Sketcher by a long shot, but this is really cool. You know, this is one of the funnest things of programming in general, but definitely programming with microcontrollers and stuff is like having an idea that's just an idea and getting it into the computer and seeing it work and then just playing with it is like so rewarding. Yeah, shake to erase. That would be cool. Does the PyPortal have a does it have an accelerometer? PyPortal. Shake to erase. That's a really good idea. Is there a regular PyPortal? Find PyPortal. Maybe not. I want to say there's something on it, right? Is it a temperature sensor? Temperature sensor. So we could connect. So that's one of the cool things about stemma. Both of these have a stemma in and a stemma out, or I don't know if they're actually in and out, but there's 2 of them, and you can use them as in and out. So we could just tack on another thing here. We could have a stemma accelerometer, and then we could just run one more wire to that accelerometer. Is one of these things an accelerometer? I have a couple stemma things. Let's see what these are. One's a light sensor. What's this one? No, that's temperature, humidity also. So, okay. I'm sure I probably have an accelerometer, one of these as well, though. Maybe that'll be another thing we can do, is tack on an accelerometer to the end, and then we'll need to get the whole case and everything, obviously. We'll mount the accelerometer inside the case, and then it can listen for shakes, and it can use that to erase the screen. Okay, so yeah, the basics of this were actually really easy to get working. The Turtle library made this super simple. So let's start with some enhancements. Let's make it to where when you press one of the buttons, I'll say for now, let's just say the right button, which is the up-down button currently, or knob, I should say. Let's look at an Etch-A-Sketch on YouTube and see, or which knob. If we do this, will it tell us which one is which? I do want to try to make it the same. What? That did not. Okay. Already on Google. It's kind of a weird thing to search for. Ooh, we could just see a person use it. Well, you know, that's one thing we need to try is spinning both and see if we can get the diagonals. Okay. So this was going counterclockwise, and it was moving down. Counterclockwise, and it goes down. Perfect. So we got that one right. Got that one correct. Let's see if we can find where they drew some of these horizontal lines. Okay, so clockwise on this knob is moving to the right. Yeah, okay, so we got that right on the first try. Perfect. All right. So let's just say maybe when you press down on this knob, we can have it cycle between some different colors. Start there. So one thing is, we need to initialize a palette. And color dot blue. Oh, this is BG color. Okay. Does it change the color of the cursor also? I don't know, do we want all of these? Can we copy paste them into a list? Oh, it has colors already as a tuple. But we want to skip some, right? We don't want black because background's black. The other thing is maybe we could make the background be like gray and make the foreground be darker gray so that we could have a mode that's like and more Etch-A-Sketch like. I love the idea of playing with different colors as well, but it'd be nice if we had one that, like, you know, tried to mimic the same colors that are on the actual Etch-A-Sketch as well. Yeah, I think we don't want to reuse this tuple all the way because we want to get rid of some, but I will copy it. And let's go here. Let's put it below this. And, oh, right. Yeah, that's a bummer, huh? Color dot. We imported this from here. We don't actually want black, but what is that? There, let's take out black. You want all the rest of these? Gray and light gray. Might not need both of those. Let's try it for now. So current color, we need a variable for current color. Cur color. Let's say cur pin color. I like to try to make my variable names as specific as I can. Cur pin color. Let's put this one after. And then let's say colors. Oh, no, we want, this should be an index though. This should be an index 0. Cur pin color index. So now let's get the button press code. Not button 1 held. We actually need released as well. We could change the logic and then we wouldn't need it, but I'm just going to try to keep it the same. So this is a button up down. Okay, up down. Okay. An extra space. This will not actually do anything, but it will print. It won't do anything on the screen, but it should print when we press the button. Got pressed, released. Perfect. So now when we press it, or do we want to do it when we release it? Doesn't matter that much, does it? I think release makes more sense though. Usually things happen when you let go of the button, more so than when you push it down. I don't know. Second guessing myself now, but I think I'll start with doing it here. When we release it, then change the color. Per pin index plus equals 1, and if per pin index is greater than or equal to the length of colors, put it back to 0. So this will make it so we cycle through the list of colors. Okay. Does this change the cursor too? No, it doesn't look like it. Actually, it doesn't seem like it changed anything, truthfully. Yeah, still looks pretty darn white to me. Oh, right. We never called pin color. Duh, we're changing this variable, but then not doing anything. So turtle.pen color is colors for color index. There we go. Ah, and it does change the cursor as well, which is nice. Now we have red and yellow. Yellow doesn't come through super well on the screen there, but it definitely looks yellow on the device. Green. That one must be orange, I guess, probably. There's blue. Okay, cool. Let's make sure that it goes all the way through the list. That was blue, purple, pink, gray. Nice dark gray. Let's push it again. Light gray, brown. Whoops, let's go up a little. Okay. Dark green. Turquoise. Okay. Dark blue. And it does move fairly slow. Sorry, I don't know if that was loud. I accidentally bonked the microphone. Dark blue. It does move fairly slow. I do think it might be nice if we step by maybe one more. Let's check the last one, dark red. And then let's make sure that we cycle back around to the beginning. Yeah, to white. Perfect. Okay. So that's working perfectly. Let's try it with, let's make a variable. Step size. We'll start on 1, which is where we're at now. Say here we go move by step size. Okay, so this should behave the same. Yeah. So now though we could change this to try 2 and see what that's like. Yeah. So this, since we're moving 2 pixels per, we get around quite a bit faster. Hey, thanks, Cornbread. I appreciate that. I guess the downside is technically if you were trying to make like a fully filled in area, you can't really. So it's tough to see. I don't know if I can, I probably can't get it to zoom very well, but right now I actually have, you know, every other pixel is filled in right there. So there's blank pixels in between. So maybe we should, what if we change the step size based on the other button? If we put, oh yeah, I never did test diagonal. That's a good point. Yeah, I guess I can just try it like this. It's a little hard since these aren't mounted. Let me give it a try here. Yeah. Which, that's about as good as I can draw a diagonal on a real Etch-A-Sketch as well, so. Complete with my inability to Etch-A-Sketch very well. Let's make it to where pushing the other button here changes the step size, and we'll just have it cycle through like maybe 1, 2, or 3 or something like that. So add the code for the other button. There we go. Button right left. Dot value. Right left held. Right left held. Right left. Left held. Left. And then let's go step size plus equals 1. And then let's just say maybe 4. So it'll cycle through 1, 2, and 3. I think that's probably enough. Because it felt quite a bit faster on 2. And I'm sure on 3 it'll be even more, to the point where you could get from edge to edge without feeling like you're just turning forever and ever and ever. So if it's greater or equal to 4, then set it back to 1. Let's also go print new step size. Step size. Should do this up here too, maybe. Print new color index. It's consistent, it doesn't really matter, but format for pen color index. Cool. We use the second button. Oh, that's a good point. Yeah, up and down. And down. Maybe we'll make a menu. Yeah. Although the turtle just takes board show or board display. Maybe, I don't know, how can we show it again? Let's look in the turtle docs a little bit. Whoops, this is the wrong thing. I do like up down for the pen, which would give us the ability to do stuff that you couldn't even do with a regular Etch-A-Sketch, because that's like one of the things, you know, if you want to make like 2 different parts of your drawing, you have to like cleverly, you know, make a line between them somehow. You can't just go from one place to the other on a regular Etch-A-Sketch, but on this one we could. Let me look in turtle some. Let's see. Maybe if we press the button, it could like hide the turtle and show a menu, and then in the menu we can like encoder through the thing. That'll give us like extra options. That way we could go to the menu to set the size or something. It'd be more of a hassle, like you'd have to press the button and then do some more stuff, but I don't know though. This gets past when it gets created. Change turtle. Display. Click on the library. What happens to this display? Turtle. It's set to underscore display. Okay, we create the group. Guess we probably also create a bitmap. Okay. I have splash, which is probably just like main group. This holds everything. Then we have a background group, which holds the background image. We don't have a background image set, but this library allows you to set a background image if you want. User-defined stuff. Add-on group. Is that part of the API? No. Foreground palette, foreground group. Okay. There's the tile grid. This is interesting. I don't know why it would be at -100. On off the screen, I guess. Sprite. This might be turtle bitmap. Okay, so this is actually the pointer. This is like the cursor, essentially. Which in ours, it's this little circle. But you can change it to be different things if you want, I think. So yeah, I think we will have to change the API up some. Up, down. Oh, yeah, there you go. You could press some. You could have different logic for while you hold one down, then you can press the other one. And if the first one is held down, then you get different logic. That's true. I think I like the idea of being able to see it on the screen, though. I would probably forget, like, which one you hold and which one you move and what it does. And so I think we would have to change this library a little bit, but I think if we change the library to where I think we could change the library to where we can hide and show the turtle as part of a group from our user code. While you push it in, but then you'd have to spin it like while it's pushed if you wanted to move in that direction, which is doable, but a little bit tough maybe. When the pen is up, can you still see the cursor? That's a good question. Let's look. You went. I guess it must already be up, but let's just call it up anyway. Yeah, it looks like, yeah, you can still see the cursor. So that's good. So honestly, I think I want to make it, I think I want to try to modify the library just a little tiny bit to where it's easier to hide and show the group. Because then we can like just hide the turtle group, show a menu, have completely different behavior for the encoders when we're in the menu state, And then when we're done, just go hide the menu state and show the turtle group again. And I don't think it will be that. I don't think it will be that big of a change. We could do double click. The buttons, I mean, the buttons themselves, they don't support double click, but we could certainly like track the time that it goes down, and then like if it goes down again, you know, before a certain amount of time has passed, then we could treat it as a double click. I really like the idea of a menu though. I mean, there are schemes we could use for sure that would avoid having to mess with it at all, but I really do like the idea of having a menu, because then we can add as much as we want, right? We could get, you know, even more complex. We could have like pen size, maybe. We could have, you know, the pen size, the up downs, the step size for how far it moves each one. Maybe even do things like images. I think there's a way you can stamp images down. Possibly in the menu, that could also be where you go to enable the like classic Etch-A-Sketch mode, where it will do a gray background and then like a dark gray or a black foreground. And that's like a whole separate mode from the other one, and it doesn't have like colors and stuff in it, maybe. This, I mean, it's just doing show the splash. So we could always go self.display.show something else. And then when we want to get back to the turtle, we can just do display.show turtle again. Let's validate that. Let's make a menu group. Menu group is a group. Need display IO, I guess, right? And let's just keep it simple. Let's put a text in it for now, which you would think I would know off the top of my head how to do, but I just copy paste it, honestly. Ports and menu. For point, I want to center this at the top of the screen, so 0, 0.5. That go the other way around. So position the other way around. Like this. And then horizontal, the X position is display width over 2. To make this better too. Rolling. And then Y position, let's just call it 10. We're going to save this. It's not going to do anything yet though, because all we did is make a group we need to menu group dot append text. Let's make this a better name. Menu label or menu title. Oh, we don't need this actually. We can make this. Oh, we can just hard code this. Okay. So now let's say when we press the right left button, well, when we release it, let's keep this code for later. But for now, let's go display show menu group. Let's make a state. So let's say state menu is 1, state drawing 0, and cur state is state drawing. So we start in the drawing state. Let's put all of this stuff that we have so far. Yeah, all of this stuff if cur state is drawing state. And here, if cur state is menu state, then we'll have different logic on the encoders, but I guess we could actually, this could go outside, right? This could be here. We'll need some more variables and stuff to track some of these things, but start this. If it's the menu state, then if we release the button, then go back to showing the turtle. So we can just do turtle dot flash, right? It's got an underscore. It's not really meant to be done, but I'm gonna do it anyway. One of the beauties of Python is private variables are just a suggestion. When we press it, it's going to switch to the menu group. When we press it while we're in the menu group, if we press it again, we're going to switch back to the turtle group. Save this. So to start with, everything just works normal. I did never put the pin back down. Let me do that before I forget. There we go. And so now when we press this, we go to menu, we press it again. Ooh, we do not go back to turtle. Okay, let's take a look here. We went to menu, fine. Print back to drawing. Make sure it's firing. It went to menu. Yeah, it didn't get tripped again. Oh, we didn't change the state. Here. Yeah, let's go. Cur state is state menu. There we go. And let's make sure it saves the drawing too. Oh. These are not working. Let's restart. From the beginning they don't work, or only after we change? Only after we change. That's because we just made the same mistake again, which is cur state. We need to change this back to state drawing. Okay, that works. Go to menu, go back to drawing, and our drawing is still there too. So that's awesome. We can switch back and forth between the drawing state and the menu state, and it will save our thing in between. It's not going to erase what we do. Okay, so now we'll need to do some stuff inside the menu. Maybe we make like a vertical list, and we can, while we turn the knob, it will go like have a cursor selector thing, maybe a little arrow that will move up and down the list and point at the different things. I need to take a 1 minute or so break here. I need to run to the restroom and fill up my water though, and then I'll come back, so be right back. All right. Okay, so now we've got states. We can go back and forth. Menu. Let's think about how do we want to draw the menu. Use grid layout with one column being the pointer. Somewhat complex though. We could just use labels. Although if we use grid layout with a single column, then We don't have to worry about all of the math to place everything below each other. It's kind of nice. Yeah. We could... Yeah, I think that's what I want to do. I think I want to use grid layout. And basically we're using it to make a list. So I am gonna go here. Cat maybe is occupied himself, so I'm gonna switch back to... Okay. So let me go to display IO, layout, GitHub. You know, the other thing is, before I get too far down this road of building out the menu, why don't I try to fix the docs in Turtle? I'll make a list and then we'll go and try to fix the docs. I know that's kind of jumping around a little bit, but since we noticed that's messed up, we should go ahead and try to fix it. Okay, so we want to make a layout. Yeah, we can just do it after this, I think. Let's call it menu list. Menu list. XY, that's probably fine. We can start with that. Width, I think we need 200. Guess it depends what our options are going to be. Keep it at 200, I guess. That's fine. Height, I think we need 100 either, but we can keep it for that for now and just see what it looks like. So grid size, this is going to be columns and rows. So we want 1 column, 2 rows. Cell padding, we can keep fine at 8. That's fine. Unexpected argument. That's not. How would it be unexpected? Child padding. Layout. Oh, this is wrong version of this file. Here? Layout, yeah, I guess so. That. I hate to delete it though, truthfully. If it does have something from a while ago that we wanted to go back to ever. Bad about that sometimes, but one of the nice things about the PyPortal, we got like 8 megs or something. There's a fair amount of space on it, so we could fix this, I think. See if it's smart enough to find layout. Yeah. So that's the real problem. I just didn't look in that list. Should have actually found the right thing in the list. Okay. So then we can basically just start adding content. me go to this new example I just made the other day. This has the one-liners here. Content. So here we go. This is making a new label, adding it to the grid. We're going to go to 0, 0 first. Going to be one size. Label. I'll just option 1. Option 2. Eventually we'll make this more rows. We'll make it 1 row for every option. Let's start like this. And let's add this to the menu group. See how that looks. Okay, so these are on top of each other because I didn't change the grid position. Column 0, row 1. There we go. So there's a lot of extra room. We don't really need maybe cell padding 8. Okay, so then the next thing is it's taking up the full height. So we'll need to probably tweak the height based on how many rows we end up having. We should maybe also move this down a little bit. I feel like right now it's in line with the title, and the title should be at the top, and then the list should actually be below it a little bit. So let's go title. Let's move that closer to the top. Let's just say 2 pixels down, and then this can be, yeah, 10 I think is fine. Let's turn on the, I just added this recently, divider lines. There we go. Probably turn them back off eventually, but for now it's nice because I can see the whole table there. We are actually still kind of, well, the divider lines are in line with menu. You'd come down just another little bit here. And I'll probably make these not be so wide. And then I think what we'll do is whichever one is currently selected, we'll put a this thing, a little arrow greater than thing here at the beginning of it. And so that tells us which one is currently selected. It's kind of hard to see there, I guess, but you know, we could probably do scale, right? This is interesting. I think, okay, this is from site packages. We could update that. Let's update that real quick. Second, we just need to know the PyPy name. Upgrade. expected argument still. Better line. Oh, there it goes. Okay, just was not caught up yet. All right. Let's do scale also while we're here. Scale. If we have too many menu items, then we might need to go back to scale 1, but if we don't have that many, then we can get away with making double size here. Yeah, that's nice. So it makes it real clear which one is selected. Maybe we could also put a space in front of all the ones that are not selected. That way they stay in line. And then as we turn the knob, it will just change whichever one has the greater than in front of it. So that way it'll change which one it's pointing to. For now, though, let me turn the divider lines back off and let's go work on that PR inside Turtle to fix the docks. And then we'll come back to this afterwards. The one other thing, actually, let me scale this title as well, and then we'll do that. Scale to... Probably want to scoot it down some more now, too. Because eventually this first option, whatever it is, it might be longer. Whatever words are there might be longer, and we don't want it to overlap with menu. So let's just go down a little more. Be 20. Yep. No, we're still overlapping, aren't we? I think we're still overlapping. Feels like menu could be further up, truthfully, though. Put this at 0. Not actually 0, though, is it? I think that's actually 0. We could go negative. It's still showing. That's interesting. Points. I have the anchor, right? 5. Row. Huh. That's strange. I don't know. I feel like negative should be off the screen. But anyway, it's a different rabbit hole. So let's try to make a PR for Turtle. And we need to figure out how to fix this. Whoops. Got a F in the arguments there. Hey there, Keith. Good morning. Hey, check this out, Keith. We made this Etch-A-Sketch. Here, let me go back. And turn the knobs, and it will move the little thing and draw the line there. Woo! It's pretty fun. But now we notice that the docks for Turtle are kind of messed up. The way that this set heading, this thing right here is all jumbled. But it's supposed to be more like this. Makes a lot more sense. Yeah, thank you. Eventually I'm gonna end up trying to print a case for it as well. Get everything all mounted up in a nice 3D printed case. We'll see. Hopefully I can see if I can get that done before show and tell this week. Try to plan on going on show and tell this week maybe and show it whatever progress I'm at. So we need to figure out if Sphynx even allows tables. Does that? Oops. And we can change colors too. That's the other thing I did. If you push this button here, then it will change your pen to be a different color. And then I was in the process of making it do like different step sizes, and that's when I decided that really I want to have a menu. So I created a menu, and eventually we'll have different options in there to change like more stuff about it. Maybe the pen size, definitely the step size, an ability to go pen up or pen down I want to have as well, so that unlike the original Etch-A-Sketch, you'll be able to actually like move the cursor without drawing. That way you could like jump over to a different part of your drawing without making a line between it. So that's kind of some stuff I'm going to put in the menu. But first we're going to try to fix this. So Sphynx docs table. What does that get us? Restructured primer table. No, not table of contents. Tables. So maybe we can do a simple table? List tables. Let's check that out. Lists and tables, okay. Oh, this is how these get rendered, okay. Although they don't give you the syntax here, but this, I think this was the syntax probably. So I think we can get away with this one. I don't think we need the complex one. The grid table. I feel like this will serve our purposes, because we can just have standard on one column and logo on one column, and then we put all those values down below. So let's go. Okay. I don't know where the name logo came from for this either. I don't. And also the one that's called logo is the default, so maybe it should be called standard since it's the default, but these have to match. Oh, I guess on this page they didn't match. Although we might still need more room here, huh? So this will be standard is 0 east. And then over here it's 0. Whoops. North. Honestly, these could be colons. It makes a huge difference, but like 0 is equal to east or north. Oh, Logo is a programming language. The first one that implemented Turtle. That does make some sense. Okay. And then, so these are the orders that are used, well, the headings that are used in that language. That does make sense. East. 180. We're gonna need more room, I think. West. Maybe not. South. 70 south west. Okay. See if this renders correctly. Nope. No bottom table border. Oh. Yeah, we need equals at the bottom. Maybe add an angle column. Add an angle column. But they're different. Oh no, they're the same. Okay, so we could have like angle column and then standard column and then logo column. Then we only have 0, 90, 180, 270 once, and it just goes across for which one. Yeah, I like that. I do like that. Let me put these equals in and just see if I got the rest of the syntax right here. And then I'll go back and do that. Do you think that's better? I guess I don't know if that needs to be bigger. Introduce error, malformed table, column span alignment problem. I think probably this needs to be as far as the widest one. Nope. Column span alignment problem, table line 8. So what's the first line? Is this line 1, 2, 3, 4, 5, 6, 7, 8? Span alignment. It's supposed to be exactly 2 spaces between them. Oh, we didn't. We're not matched here. There we go. Make sure it looks right. Let me go to Firefox. Yeah, that is so much nicer to understand. I guess this might have just been the old syntax, or I don't know. Maybe nobody just ever tested it in Sphynx. Let's make the third column though. I like that idea. So space. We're gonna need more spaces, but let's start with 2. Then here, back. So I don't know how many we need. Angle. Oh. Oh, 0. Then 90. 180. Okay. Guess these don't need to be as long anymore. I don't know if it's going to be mad if they're longer than they need to be. it seems like it succeeded. Nice. I think I want to put mode up here though, to be extra specific. We're gonna have to mess with all the spaces again, but that's all right. Character. Sorry, I wasn't paying attention. I'm not sure exactly when you said that I got in it, but we're gonna have to. Here. Make more of these. Okay. There we go. Okay. Now let's just make sure I got these correct. I think I did, but we definitely want to double check so that we don't docs wrong. So 0 in standard mode is east, in logo mode is north, 90 in standard mode is north, in logo mode is east, 180 in standard mode is west, logo mode is south, in 270 in standard mode is south, 270 in logo mode is west. Okay, so we got those matching. So now we can delete this one, and then we can copy this because there's, need to copy it? Maybe not. There's a set H, which is the same. Okay, it just copies. Okay, we don't need to copy it actually. It does carry over automatically. Cool. That is much nicer. Is there any other parts of the docs where it talks about these? There's dot size. I wanted to change that in the menu, I think. You know, the other thing I need to do, it's not related to this project at all, but there is still an open PR that needs some work on the turtle library. OnDisk bitmap was being weird on this library. When we fixed it for CircuitPython 7, it does some stuff that doesn't make a whole lot of sense. So I need to go back and actually figure out how the stamps and things are supposed to behave. Okay. Doesn't look like there's anything else that references the directions. Yeah, this is so much nicer. Thank you for the idea to use the table. For a couple folks presented that idea. I appreciate it. Okay. Okay. So let's go here. Let's go Make a new branch from main. Track. Recommit. Oh, okay, I just have extra files that aren't checked in. That's fine. It's gonna fail reuse, but I wish there was some way to make reuse ignore files that are not checked into the repo. That's worth a quick Google. I suspect I won't find anything, but reuse pre-commit ignore files not checked in. If we get super lucky here. No. Oh. But this is not true. I don't know if it's true of Pylint, I guess, but reuse is definitely... Okay. We're going to peek our heads down this rabbit hole. We're not going to go all the way in, but... Recommit config. How does reuse work? Oh. Okay, it's all hidden inside of here. I have no idea how it works. Probably something inside this repo, I guess. Okay. Yeah, we're not going to chase this too much further. Doesn't say anything. Oh, well. Okay. We'll live with that for now. And we just know that those files are not checked in, so it doesn't actually matter that they failed reuse. Did we pass the rest of the stuff, though? Black? Yes. Pylint? Yes. We should be fine when we push it, I think. And let's just... triple check docs, builds, yep. And that this looks right. Does. Okay. So push this. Check our change here, which is get rid of the broken table, add the good table. That's it. Hit message. I don't have a remote. I have a fork. Like it. Oh, maybe not. It lets you add a remote even if fork doesn't actually exist. That's interesting. Now I do have a fork. I already have my remote. Okay. Angles map to which directions based on whether turtle is in standard or logo code. This. It's like this. This is it's not old yet until we merge this. Okay. That's in. I'll try to keep an eye on this just to make sure nothing makes it fail the CI. But we ran everything local, so and the only thing that failed on my end was reuse, which are for files that are not checked in, so I don't think it should fail in GitHub. Okay. Yeah, it is much better now. So I got about maybe 30 minutes or so left. I think let's keep working on the menu a little bit more. So what do we want to do? Let's make the actual things that we want in the menu. So we want, let me think here. So I kind of want, we want to do this. What if we... What if we... What if we long press to get to the menu? So what if we hold this down for like a full second or something? That takes you to the menu. But if you just press and release, then it will lift the pen. Yeah, that way the most, because I think color and pen up, pen down, those are probably the two most common things that a person would want to do. So let's make those on single press. Single press of this cycles through the color. Single press of this raises or lowers the pen. And then a long press of this, if you press and hold it, then it will take you to the menu. So let's make that logic. The other thing we can have in the menu is the color, to where maybe we can actually have a list for the color and you can scroll wheel through it. That way it's quicker than, like, you know, if you're at, you know, white and you want to get all the way to turquoise, like you'd have to press, but you could go to the menu and then just turn the dial to get down to there. So that would make it a little bit nicer. So let's do the long pressing. So how does that work? Let's see. So we need to press down time. Button. Right, left. Press time. Starts on 0. We have time. Yeah. Import time. Time it. Make a polar coordinate Etch-A-Sketch mode. How does polar coordinates work? Are those, they're like round? Are they round instead of XY, like rectangle? Okay, so we need a, can you query the down up state? Put the pen down. Pen up. Oh, clear. That's the other thing we'll put in the menu, is clear the screen. I do want to do shake. I like the idea of putting an accelerometer and making it shake, but we don't have the accelerometer yet. Radians / angle distance from the origin. Hot minute since I've been used them. Yeah, that'd be interesting. It would be cool to have like totally different take on it. I mean, that's the nice thing about it being digital. Like, we can really go kind of far away from, you know, we're not bound by the hardware, right? The hardware of an Etch-A-Sketch works only one certain way, but we can go outside those bounds. Doesn't look like there's a way to have it return whether the pen is currently up or down. So let's just make a Boolean for it. Ooh, hide turtle. Does that hide the entire thing or just the cursor? Just the cursor. Okay. All right. So maybe we'll have an option for that as well. You could have an option that would turn the cursor on or off. You know what would also be kind of cool is maybe we could do it, because like the cursor on a Etch-A-Sketch is kind of like just 1 pixel pretty much. It's like 1 pixel above or below where the thing is at, so really I guess it's like 1 pixel in front of, depending on which direction you're going. Be cool on the like mimic the Etch-A-Sketch mode if we change the cursor up to have it just be like a single pixel, and then maybe we can swap it to be in front of whichever direction you're facing. But we could also have an option in our menu to turn the cursor on and off. So we need a Boolean though for the pen down. Down is true. This sets it to down. Don't need that anymore. So on a single click here, we're gonna say we don't want to show the menu. On a single click, we want to go pen down is not pen down. And then we want to go if pen down turtle pen down else turtle pen up. Let's test that. So I can draw it. I can go click once, and then I can move it. I can go click again, and then draw it. Perfect. Okay. Yeah, I don't see an is down either. I think we'll just keep it with our own. Ooh, a spirograph would be fun as well, huh? Yeah, that would be kind of cool. So like as you spin it, it draws like an arc, and then maybe the other one controls the radius of the circle that it's making it arc. That would be kind of fun. Yeah. Yeah, I like it. All right, so that's working. So we want the hold down logic though. So I think we say when we press it down, we say button press time is time.now, which is monotonic. And then at the end of this, we can just say if button press time so actually we need if button right left held. If it is down, then if the time that it went down, the current time, time.monotonic, minus the time that it went down is greater than, I'm going to make a new variable called menu hold, menu press, threshold. Then we go to the menu. Okay. Oh, it doesn't give me just make a variable. I don't know, does time monotonic, does it count in seconds? I want to say it counts in seconds. Yeah, counts in seconds. So let's say if you hold it down for, say if you hold it down for 1 entire second. Yeah. So the next thing though is if we hold it down for 1 second, this is going to take us to menu state. But then as soon as we release it, this logic is going to trip. So we need to ignore the first release, basically. Otherwise, it's just going to take us right back to drawing. So how can we ignore the first release when we're in the menu state? Let's say button right, left, ignore, release, false. When we go to menu, set that to true. And then we say, if not, ignore release, then do this. Oh. Else, if it was ignored, then we just set it back to false. Yeah, so the first time we release it, we go to else, we set it back to false. The next time we release it, we get this logic, which will take us back to drawing. Okay. Save this. Let's break out a REPL. Okay. Draw something. Hold it down. That didn't work. That's because this is inside the main loop. It's inside the main loop. We need this logic. Need this inside here. Really. Maybe this? I think this way will work. Draw something. Oh, there is a turtle is down. Hold it. We go to the menu, we let go. No, still went back. Yeah, we never set this. No. Yeah, we did. Set this to true. Release. So I'll go back and get rid of my my pin down variable. Do we initialize? I'm in the menu values. I'm not sure what you mean, Keith. I feel like is the ignore is kind of like that. I guess it has a different name, but so not sure why it's not working, truthfully. So when we get released, then let's print, and let's say print ignore format. Okay. Draw something. Press and hold. In the menu, release. We got 2 releases. Because button held. Button held didn't change. So we got a release on the next iteration through the main loop also. This should do it, maybe. Go to menu, your release. We stay in the menu. We press and release again, and we go back to drawing. There we go. I think it is like that. I just mentally running through my debug list. One of them is, if I enter a state, are there values that need to get set right away? Yeah, there probably will be. There probably will be. Like, we'll need a variable for like the current index of the item that's selected in the menu. We'll need, I think we might need to know, we need to know the current encoder values. I'm not sure about the current encoder values. We might not need those, but we may. I'm not sure. Because we'll need to, no matter what the position is, we'll need to go up and down the list based on when the values change. Let me use isDown though. Thanks for pointing that out, by the way. H-line. Yeah, there is totally an isDown. So we're just gonna say we don't need pin down. Find the spots where it's broken now. I guess it's not broken for some reason. Because we set it right here, I guess. So we do this. If not, turtle is down, then put it down, else pick it up. Yeah, if it's not down, put it down. If it is down, put it up. Make sure that still works. Cool. Draw something, pin up, move. Yeah, pin down, draw something. Okay, perfect. All right. So let's see. Got our menu state going off a long press now. So we do want, let's try to work on scrolling through the menu. Let me add a couple more things to the menu as well. I think I'll have a few more than 2. I'll work on scrolling, and then I may call it a day after that. Got about 20 minutes or so left in the time I usually stream, so let's go. Let's make some more variables like selected index. We'll start on 0, and I think we'll set it to 0 when we change states as well, just like Keith was mentioning. Selected index. What else do we need? We probably need some more, but I'm gonna start with just this. So let's go, while we're in the menu state, we want our encoder logic. Pretty much have the same logic here, truthfully. Except for the differences, we won't be doing these things. And so how do we want to do it? Do we want, so I feel like you should turn the same knob that you held in order to scroll up and down the menu. Or should you turn the other knob? Because the other knob is the up-down knob. We are going up and down the menu. Let's do the other knob. Let's do the up-down knob. So up-down, if the position went up, that means we turned clockwise. So we want to, yeah, and this is where it gets weird actually, because our indexes are going to be reversed. Because our 0 index is at the top, and our 1 index is below it. So we actually want to lower the index. Selected index minus equals 1. Minus equals 1. If selected index is less than 0, put it to I'm gonna make another variable for menu items. Could be a tuple, I guess, right? We don't need to add to it. Okay, let's do pen size, step size, and let's make a clear. Clear. I'll add some more later, but let's start with 3. So the menu here, it's actually going to be grid size is length, menu items, and then we can loop or item in menu items. So space, we'll start it with a space, and then I'll make a function that it's like sets the arrow on the right one. Space, format, item. Position, we need to enumerate. I. Let's call it index. Enumerate. And this will be index. Okay. Okay, let's make sure that works. We should have 3 things in the menu now. Okay, we do. None of them are selected, so let's make a function that will show the selection for us. We could put it down here. Def show menu selection, and it takes the selected index, and it's gonna go. We need to iterate through the labels, and we need to take off the arrow sign if it's there of all of them, and then we need to put it onto the one that's selected. So iterate through the labels. I think menu list is a group. Group we can access. So let's go for index enumerate item in menu items. Let's go through this list. And then menu list. So we have this now, actually. This seems like the right way to do it. Get cell, so we want column 0, row index, and text. Make it to a variable. Okay. Let me just make sure this is working. We're going to print the item label, and that's it. So let's just call this and make sure it prints all the right items. Show, just put 0. Shadow's name. Doesn't really matter, I guess, but honestly, we could make them this underscore names up there too, or not even using item. Okay. Oh no, it failed. Too many values to unpack. Oh, enumerate. Enumerate. Layout doesn't have get cell. It does. I got the wrong version, maybe. Up install layout. Okay, there we go. So we are properly looping through our labels. We're getting our text out of the label. So now we go. Now we. Now we go if index is not equal to selected index, then how do you replace a character based on its location? Does that work? Can you do like replace I for the index of the character and then replace it with the new character? Or do you have to replace by the actual character itself and not the index? Python box string. Oh, just take me to string. I just want to go to string. And I could just do this in the REPL, I guess, right? It's probably faster. What is this? Index. Starts with. Okay. So we have R strip. I assume we should have L strip, yeah. So if our string was like this, and we said L strip this, then we end up with just something. And if our string was like this, and we said L strip space, and we also just end up with something. So then we can say if index is not the selected index, then item label L strip this, and then set it back into the text. Else, if it is the selected index, then we... Oh, no. We need to add the space back. Yeah, we need to add the space back. And then if it is the selected index, we strip the space and then set it back with the pointer. Don't need print anymore. Okay. So after we run this, we should end up with a pointer on the first item in the list. And we do. Oh, but we have an extra space? We don't. I mean, I guess we don't, right? It looks like there might be an extra space there, but everything is still in line. Oh, you know what? We do have extra spaces because... this returns a new thing. Right, this is not modifying item label. So we actually need item label is equal to, and then the same thing here. And the other thing is, this is only removing the pointer, but if the thing isn't the currently selected thing, and if it wasn't currently selected before, if it used to have a space in front of it, we're going to end up with two spaces. So we need to actually strip the space as well. Do we need to do the same thing here? Yeah, because then we would end up with 2 arrows if we don't. So basically, we want to remove the first character no matter what it is. It's either going to be a space or an arrow, and we want to remove it either way. So maybe it would make sense to, like, use slicing or something instead of this, but I'm going to leave it this way for now. Remove the first character. If it's not selected, we add the space. If it is selected, we add the pointer. Yeah. So let's run this, and that I think that should make it so we don't have an extra space. Yes, it did. Okay, so let's hook up to where we can scroll through the list by changing this rotary encoder, and then I'll call it a day after that, I think. So we should be able to just call... I think we should be able to just call this with new indexes. So if we're in the menu state, this is already changing the menu index. We need the reverse logic here. We add one. We turn it the other way. If we are greater than or equal to length of menu items, then we go back to 0. And actually we want to go to -1 here. Length -1. Because it's 0 indexed. Okay, and then we just can call show selected and use selected index. Go to the menu. Turn. That's not doing it. Okay, let's Oh, I did the wrong one. Ah, yeah, it's working. Cool. So if I turn it to the right, it goes up through the list, and it wraps back down to the bottom when it gets to the top. If I turn it to the left, then it goes down through the list, and it wraps back to the top from the bottom. Cool. So then the next thing I'll do is, like, when you press the button, then it will do the action for that menu item. So if you press the button on pin size, you know, maybe it will cycle through a couple of different sizes. On step size, same thing. It will cycle through a couple of different step sizes, and then on clear, it will call that turtle.reset or whatever, the one that clears the entire drawing for us. And I guess we'll also need an exit, right? We need a way to get back to draw mode. So let's add a exit menu. Let's hook that up, actually. It'll take a few more minutes only, I think. Let's hook that one up. So let's say when you're in the menu state, let's get the button clicks for the up-down button. Okay. Rid of this stuff. When we release the button in the menu state, if the selected index is I don't want to, I could just hard code it, I guess, but yeah, I guess I'll just hard code it. Nice. That looks fun. How did you draw that? Did you draw that stuff with Turtle, or how did you draw that stuff? That's super cool. Here, let me, I could pull this over here. It'll make it bigger, I think. I guess it's fairly big anyway, but yeah, that looks like fun. Okay. Okay, so if the selected index, I'll just hard code it, I guess, for now. It'd be nice to not have to hard code the number, but do we have index of? Does index of exist? New items? Just index? Python index of? Use the D-pad instead of rotary encoders. Nice. So it is with the turtle though, right? Do we have a turtle in here? Turtle. Just index. Index. Does it go -1 if it's not in there? We'll figure it out. So we could say if the selected index is equal to the index of exit menu, then we change the state back. I don't. Oh, I do have it. Currently it's set to here. Let's take this. This makes it actually so we don't have to worry about the ignore either, but if we end up hooking up a button, any kind of button that does something with the left encoder, then we will need this, so I'll leave this logic, but for now we're going to put this here. Go back to drawing, change the state, show the turtle. Yeah. Nice. Yeah, that's cool. I like the D-pad one too. That'd be a fun one. Okay, so let's check if this works. Go to the menu. Scroll. Enter. Yeah. And we can save it, right? We do this. Go to the menu. Oh, that's interesting. It keeps the index on whatever you were last. Maybe we should set that back to 0, I think. Yeah, let's do that. When we go to the menu, set the selected back to 0, and then show 0. And we don't need this up here. We're gonna do that right before we go to it. Okay, and this will actually be the last thing I do. I know there's always one more, but I think this is a really good start for this project. We hold this, so now we scroll, go to exit, and then press, and that gets us back. Cool. And then so we would basically just add more branches to this right here that check the different indexes and do the different things for each one of those. And we'll probably also add like the current pin size number. We'll stick that on the end of the string, and the same thing for step size number. But all right, I think that's going to do it for today. So thank you to all the folks that tuned in on Twitch and YouTube, and all the folks that hung out in the chat with me here. I feel like we got pretty far on this project. This is I'm super excited about the way it works. Like, this part of it here is pretty much exactly what I wanted to do. Hey, thank you there on Twitch, CyberSecMurph. I appreciate the follow. But I'm super excited about the way we got this working. You know, this is exactly what I had imagined. So I'm glad that that it came out this way, and that it was. See if I can the other way maybe. I'm glad that it came out this way, and that it was relatively easy to do. So I'm excited to finish up the menu, add some more options to it, and then get a case designed and print it out and get everything all buttoned up inside of a case. So I will. I think I'll plan on going on Show and Tell to show whatever whatever progress I end up making. So hopefully I'll have a case, but I'm not sure. But I'll plan on showing it on there this Wednesday, so check that out if you want. Show and tell is always a lot of fun. Again, thank you everyone that tuned in. Dexter, Keith, Johnny was here. Couple folks on Twitch real quick. I'll go through those again real fast and then I'll call it. So Cybersec, Cybersec Murph, Beep Boop Beep, and C Films, and H-Line. Thank you to all you folks for hanging out with me as well. And I'll see you next week. I stream at the same time, so 10 a.m. Central on Saturdays is when my stream is at. Usually I stream every week at that time. If you're interested, you can catch me again next week. That is all for now. Thanks.